Problem number 2. TV show ratings. In a survey on TV show ratings, 1,000 viewers were asked if they regularly watch a certain singing competition. Of the 1,000 surveyed, 338 answered yes. The network considers canceling the show if less than one-third of the population regularly watch it. Can you help the network decide using hypothesis testing at 10% level of significance? Use the p-value approach. Now, what is the topic all about? It is about the proportion of TV viewers who regularly watch a TV show on a certain singing competition, and that is our parameter of interest. Now, what is the hypothesized population? Remember that the network considers canceling the show if less than one-third of the population regularly watch it, and that is our target population proportion. One-third, if you convert it into decimal, is a repeating decimal. We just say 0.333. So our null hypothesis is p equals 0.333. If you'd ask me why I considered 3 decimal places, it's because if I'll divide also the proportion based on the survey, 338 over 1,000 is 0.338. Since there are 3 decimal places for the observed proportion, then I also consider 3 decimal places for the population proportion. Since the network will consider canceling the show if there are less than one-third of the population, then our alternative hypothesis is p is greater than 0.333. Now, what's our assumption? Our assumption is a sample of 1,000 is large enough. By the central limit theorem, the data is normally distributed. Let me check. Our statistical test, since there are 1,000 being surveyed, is z-test for proportions. Let's go back. Let me correct this one. It should be less than, not greater than, since the claim is less than one-third. So it is a one-tailed, left-tailed test. The level of significance is at 0.10, as stated in the problem. Now, let's solve for our test statistic and p-value. Let me show how we get the test statistic of 0.34 and a p-value of 0.3669. Now let us solve for our test statistic. The hypothesized population proportion is one-third, or we say it is 0.333. Q sub 0 is 1 minus P sub 0, and that is 0.667. We have 1,000 for the sample size, and out of 1,000, 338 out of 1,000 said they're watching the TV show. So, our observed proportion is 0.338. Let us substitute it in the formula. We have 0.338 minus 0.333, all divided by 0.333 times 0.667. Divide them all by 1,000. If we'll solve this one, we'll get a z-value of 0.335. And this is our test statistic. Let us solve for our z-value, or for our p-value. Our test statistic is 0.335. And since our z-table only has 2 decimal places, we could consider 0.34. So we draw our curve this way. From 0 to 0.34, the area being covered is 0.1331. Please refer to your z-table. Remember that from 0 to negative infinity, the area is 0.5. And we're looking for this area in the left tail. This is a rejection region that is being left. So that is zero point 0.5 minus 0.1331. With that, what's left is 0.3669. And this is our p-value. If we evaluate it, this one is greater than our alpha, which is 0.10. Thus, we do not reject our null hypothesis. Now we will consider the decision rule for the p-value approach. We say we reject the null hypothesis if our p-value is less than or equal to alpha. But if our p-value is greater than our alpha, then we do not reject our null hypothesis. Our p-value is 0.3669, and that is greater. That should have been greater. Please edit that one. That is greater than our 0.10 level of significance. Thus, the p-value is greater than our alpha. And if the p-value is greater than alpha, then we do not reject our null hypothesis. Thus we state, therefore, we do not have sufficient evidence to reject the null hypothesis. Then we state our null hypothesis. Thus, the proportion of viewers regularly watching a TV show on a singing competition is equal to 1/3 or 0.333. With this, since it is equal to 1/3, not less than 1/3, then the network can continue airing the TV show. This ends our topic for this time.